Okay, this is a Euclidean geometry problem, and I've written the proportion theorem at the top because it's relevant to this question. A segment parallel to the side of a triangle cuts the other two sides proportionally. We'll see that in a minute. Let's first look at what we're given. PA is equal to 4/9 PQ. So we could write that as a ratio. PA is to PQ as 4 is to 9, or maybe more helpfully, PA is to AQ as 4 is to 5, because that is the leftover piece. So PA we could write as 4x, AQ we could write as 5x. We also know that 2 PB is equal to BR, so I might label BP as y and BR as 2y. And another thing we know is that BC is parallel to RA, and this is a little clue that we are going to be dealing with the proportion theorem. So before we start the problem, let's actually look at a couple of triangles that might be of interest as we think about this problem. So RAP is certainly one that might be of interest. We can see that BC cuts PR into a known ratio, and we might be interested in the other side. And we also might be interested in this triangle, maybe not as obvious, BQC, because AD is parallel to one side BC. So let's look at what we're being asked to do, and we can consider the triangle that we need. So we're interested in finding BD, the ratio of BD to DQ. So I might go to the triangle first that contains BD and DQ. There they are. And unfortunately, we do not have the ratio of any one of the sides here, because PQ is not one of the sides of this triangle. So it would be nice to figure out the ratio, if we can, of CA to AQ, but that is unknown right now. We're going to need to look at a different triangle to find that. So let's go to the triangle that might be helpful there and that we know something about, RPA, and look at this one. Now we notice that PA is split into a ratio of, we'll call it Z or Z and 2Z, and all of that is equal to 4x. So maybe we could say, well, Z plus 2Z is equal to 4x, so 3Z is equal to 4x. Z is equal to 4x over 3, and that might make sense to you, because if we have a segment that is equal to 4x and we divide it into 3 parts, each one of those will be 4x divided by 3, 4x divided by 3, 4x divided by 3. So if this is PA, and C is right here, we now know that the ratio CA to AQ is going to be 4x over 3 to 5x, which we can simplify to 8. Sorry, that should be an 8x over 3 to 5x. We can simplify that to 8x to 15x, or just 8 to 15. sorry, the CA was equal to 8x, not 4x over 3, 8x over 3. And the second question is about areas. Well, if we have two triangles that have the same height, any two triangles that have the same height, the ratio of those areas will be equal to the ratio of the bases. Let's see how that looks in this problem. Just erase everything here. The two triangles we're considering here are PRA PRA, oh my, PRA, there we go, and QRA. And if I were to draw the altitude, the height for both of these, that's the hint in this problem, it's the perpendicular, and it is the perpendicular to the base, which in one case is PA, in one case is AQ, but they are all a part of the same segment, PQ. So the ratio of those areas, the area of triangle PRA over area of QRA equals 1/2 the base, which would be PA, times the height, which I'm calling H, and 1/2 the base, which is AQ, times the height, which I'm calling H, and so that is just equal to the ratio of the bases. And we know the ratio of the bases PA to AQ, because that was back at the beginning of the problem, 4 to 5. There we go.